an economics problem. So we're going to be using the equation R equals XP, P representing the price of an item in dollars. So let's start with the first one. The first example is giving us the p-value, which is -1/6x plus 100, and it is giving us a constraint, which means that x can only be between 0 and 600, which kind of makes sense since notice that the negative numbers are not being included. Obviously, you can't charge negative, you can't have negative quantity of items. And I'm assuming 600 is the limit since a company can only make so much at a time. The first thing we're going to do is we're going to find the model that expresses the revenue R as a function of the price X. So which means we're going to be using the formula R equals X times P, and then we're going to plug in our p-value. So this is going to be -1/6x plus 100, and then I'm going to simplify by using the distributive property. So R is equal to -1/6x squared plus 100x, and that is the model. All right, now I'm going to use that model to figure out a couple things. So for starters, what would be the revenue if 200 items were sold? Well, pretty easy to figure that out. Let's just go ahead and plug everything in. I know this is going to be quite quite big numbers, so try to figure out the best and easiest way for you to calculate this without the calculator. So we get R is equal to 13,333 with 33 cents. So that's how much money we would make if we sold 200 units. Now, what is the quantity X that maximizes the revenue, and what is the maximum revenue? Now, in order for us to be able to answer this question, it's important for you to understand that we're dealing with a quadratic function. Specifically, we're dealing with a quadratic function that is concave down. So our vertex is our maximum point, which means in terms of this problem, it is the maximum value or the maximum revenue that we're going to be creating. That's why quadratic models are very useful in economics, because we're basically looking for that area. So it's asking us for two things. What is the quantity X that maximizes the revenue, and what is the maximum revenue? So in terms of a quadratics, the quantity X that maximizes the revenue, that is asking for the location of the vertex, which in other words would be our AOS, or our axis of symmetry, given by -b/2a. And what is the maximum revenue is asking us for the y value. What is f of -b/2a? So let's go ahead and find that out. So let's start with the first one. We need the location, which means we need the AOS. So that's x equals -b/2a. So if we plug everything in, that's going to be -100 times 2 times -1/6, which eventually gives us 300. So we need to be selling 300 items in order for us to reach that maximum. Now, let's go ahead and find the maximum. So we're going to plug everything into our formula, which is going to be -1/6. We're going to plug in the items that we need to sell, which is 300. And once we calculate all of this, this is going to be $15,000, which means the maximum money that this company could hope to make is $15,000 if they sell 300 items. And lastly, what price should the company charge to maximize the revenue? So we know that we need to sell 300 items. What is the price of that item? Well, if you remember earlier, we got an equation of P, which is the price in dollars. So what we're going to do is we're going to take that equation, which is P equals -1/6x plus 100, and we're just going to go ahead and plug in our X value. So this is -1/6. We're going to plug in the 300. And then just simplify. Sorry about that. And then we get negative 50 plus 100, which eventually gives us a price of $50. So we need to be charging $50 per item. We need to sell 300, and our maximum profit is going to be $15,000. Okay. Now, what if we need to create a model based on, I don't know, a more real, well, not a real, based on, I don't know, kind of a picture or something physical that is not necessarily economic, something physical that is there. So for instance, David has available 400 yards of fencing and wishes to enclose a rectangular area. So if we draw a picture, we need a rectangular area. This is gonna be my length. This is gonna be my width. And we know that we have 400 yards. So that means that all of this plus this plus this plus that equals to 400 yards. Now, why is that important? Well, what I just mentioned is the perimeter of the rectangle. My perimeter is 400 yards. I have a total of 400. Well, it's asking me for area. Yes. I know that area is gonna equal to width times length, or length times width. It doesn't really matter. Actually, let me switch that. Length times width. Now, the problem with it is that there's too many variables. I have A, I have L, and I have W. Usually what you want to do is have only one single variable. Now, remember, we're also talking about maximizing things, which means that we need to be able to use, we need a quadratic function. Now, in order for us to do this, we need to use the information that was given to us. So for starters, they're giving us the perimeter, which is 400. Well, perimeter is basically the side plus the other side plus the other side plus the other side. In this case, we have a rectangle, so we have 2 lengths. And if we add that to the 2 width, that should give me the perimeter, which we know is 400. All right, so we could use this in order for us to make the model. Now, remember, or not remember, but read that it wants the area in terms of W. So we got to turn everything in terms of W, which means in my area formula, I need to get rid of that L. Well, how do I do that? I'm going to use my perimeter formula. So I'm going to minus that 2W to the other side. So I have 2L equals 400 minus 2W. Then I'm going to divide everything by 2. So length is equal to 200 minus W. Well, I'm going to use that, and I'm going to plug it in for L so I can have everything in terms of W. Well, now this is going to be A is equal to 200 minus W times W. And I can simplify this by using the the distributive property. So eventually my model is 200W minus W squared. And there's my model. So that's the model that is going to give me an area. So now what we got to find is for what value of W is the area the largest. So what this is asking me is, once again, if you look at the properties of a quadratic, the maximum is right there. It's asking me for the value of W, which in other words is asking me for the location of the maximum, which we know we can find that by finding the AOS, or the axis of symmetry, by using negative b over 2a. So that's what we're going to do. So x is equal to negative b over 2a. Negative b is 200, so negative 200 divided by a, which is negative 1, so negative 2. And my axis of symmetry is going to be 100, which means I need 100 yards to be able to find the maximum area. So the value of W needs to be 100 yards. Now, the next question is, well, what is the maximum area? Well, now that we know what W needs to be, then we can actually find the maximum area. And remember, area in this specific example is given by 200W minus W square. So let's go ahead and plug in everything. 200 times 100 minus 100 square. And if we calculate this, we should be getting 10,000. So 10,000 square yards. All right. So what I want you to do before you get started with the homework, I want you to try example 3 by yourself or with your shoulder partner, and then go ahead and check the answer. Whenever you finish, go ahead and check the answer on Canvas. I will attach the key to Canvas. All right. Once you're done with that, go ahead and get started.